All right, everybody, welcome again to another OpenShift Commons briefing. If you're watching us on Facebook or YouTube or Twitch, we are going to have live Q&A at the end as always, so ask your questions there and we'll aggregate them and throw them back at the speaker afterwards. And today I'm actually really excited for this conversation because it's a conversation you hear bandying about the internets often, and everybody seems to affix the word ops to the end of their things, whether it's DevSecOps or DevOps or MLOps or AIOps. And at Red Hat, we've been doing a lot of work around, and GitOps too, thank you, Waleed. So there's an ops for everything. And in the ML AI space, we've done a lot of talking in the past and comments around this. And I invited Zak Berrie here, who's the machine learning specialist here at Red Hat, and to help us have a conversation about these three areas. I'm sure we'll bandy about into other ones as well. And as he put it so succinctly in the description, try and come to a unified theory, field theory of ops today in this conversation. So Zak, I'm going to let you introduce yourself, take it away, and then we'll be doing some Q&A, ask your questions, send us your opinions on all of that, because everyone has an opinion about all of these things, but I'm hoping Zak can help us tease out a good approach to all of this today. So thanks very much, Zak, for joining us.
Yeah, thanks, Dan. And you know, this is also very much an opinionated discussion, right? This is my view on the world, and I'm happy to take criticism or to hear where you think I might be on the right track or on the wrong track. You know, when it comes to discussing the meaning of terms and what those terms mean to us, it's always something that is worked out through usage. So this is really just me putting my stake in the ground of what I think these terms should mean, and then what these terms mean for us in the discipline of IT. So the agenda, I'm going to do a quick biography of myself. I'm going to talk the background or the problem statement here for really for most of the time here. I'm going to go through a glossary and again make my arbitrary attempt to disambiguate these terms. I'm going to attempt to peer into the future and see what the near-term future might hold around the problem statement that we've come up with, and then I'm going to make an attempt to address a path forward, right, and how that might be meaningful for us. So my biography: I was a Linux admin on a DevOps team back in what we now call the .com era, right? 98 to 04 or something like that. And since I came to Red Hat and since I started doing a different kind of work, the term DevOps was coined. But looking back at what I did in those days in the early web operations, it really was a DevOps model. We just didn't have a name for it. I spent a year and a half as a trainer here at Red Hat, and then I spent a decade as a solution architect, mostly covering strategic accounts out in the West Commercial Group here in the U.S. I got up to the level of a principal solution architect. And then for the last 2.5 years, I've been working as a solution sales specialist here at Red Hat in the same rough area. And my particular role this year is around machine learning workloads and however those work across various platforms that Red Hat has to offer. So not product specific, more workload specific. So this presentation is from the point of view of an IT veteran. I'm not a data scientist, I'm not a data engineer, and so I would hope that anything that I get wrong within that field is perhaps not as wrong as it could be, or more right than wrong. And so perhaps if you're a data scientist or a data engineer that's watching this, please consider this to be of entertainment value only. So background. A little nod to Conways Law here, because this is going to be part of the background of everything that we talk about. So there have been some earlier transitions, right? So we've moved largely from the use of proprietary software to open source software, right? At least a partial movement in that regard. A move from big iron to commodity hardware, from physical servers to virtual servers, from kind of a throw it over the fence mentality towards a DevOps mentality, where software developers would write and test somewhat in isolation, and then they would hand it over to an operations team to run it, and now it's your problem. I don't know what the proper term for that throw it over the fence, what the pre-DevOps system is. I'm open to suggestions on what you might call that. I've heard people say ITIL, but ITIL is not correct. ITIL can still work within the context of DevOps. So I'm interested to hear what you have to say for that. And in terms of the actual development methodology, we've tended to move from waterfall methodologies towards agile. And then there's been a move towards containers with orchestration. And I don't buy into the virtualization leading to containers thing. I think that's totally wrong. They solve different challenges. But what I do think is worthwhile to consider is a transition from app and configuration automation towards containerization with orchestration. So this would be more towards well, I spent a lot of time working with clients maybe a decade ago who were trying to use Puppet or Salt or CF Engine or something like that to manage their whole pipeline and manage how they delivered applications, not just with random configuration files on Linux machines, but and it seemed like that was a very, very difficult way to solve that challenge, and that largely the ability of, rather than thinking of the configuration of the OS as a stateful thing that needs to be reconfigured, and you need to keep track of that state and so on. Rather, the better approach is to turn it into an immutable widget and then simply move widgets around. Right, seems to be a better approach. And then there's been a move towards on-demand or cloud resources. Cloud can be defined in different ways. I tend to think of it as just the ability to have the resources on demand when you need them by just calling an API or something like that. I'm also interested to hear, and maybe put this in the comments. What should the retronym be for the time before cloud computing? I haven't heard a good answer there. So a retronym being a term like landline, right? Nobody called it a landline before there were cell phones. It was just a phone. So what's the retronym for the time before we had cloud resources? I'm interested to hear in the comments. There's also a revolution happening in data right now. That could be a whole talk of its own, so I'm going to leave that somewhat out of scope. Okay, so I'm going to frame up these transitions because I believe that we are in the midst of a similar transition right now, and that is a transition that's about implementation of data science, artificial intelligence, machine learning techniques into IT. Okay. So big questions, what's next, right? Where are we heading from here? What can we learn from earlier transitions? And I mean that not just in terms of that we learned from the transition to virtualization that you should virtualize, but also what do we learn from what the IT as an industry went through as part of those transitions? I mean, a thing that is very much sticks in my mind from the earlier transition towards virtualization is that you would often have conversations with application teams or DBAs or so on and so forth when an IT organization, when an ops organization was attempting to virtualize, where there was an immediate resistance or no, don't virtualize my application. And the thing that I think could be learned from that, right, the important lesson from that earlier transition was that if you're going to make a major change, the benefits of that change need to be distributed widely, right? You can't have a sort of narrow benefits that are applied narrowly, right? So that's what I mean by what can we learn by earlier transitions. What are the other lessons that are embedded in there? What have we learned about people and organizations that are important here? The more time I spend in this industry, the more I find that my job is about trying to teach organizations and trying to change how organizations work rather than a particular technology focus. The technology needs to support the organizational change and the way that people think and believe. And how do we apply these lessons to our benefits? Okay, so these are the big questions that I'm trying to frame up here. So the Red Queen. So this I think is an important analogy, and I'm going to touch on it a few different times here, or important idea. So this comes from Lewis Carroll from Through the Looking Glass. There's a scene in that book where Alice is attempting to run away from the Red Queen, but she finds that the ground is moving underneath of her, matching the speed at which she runs. So she says, and so the Queen says, "Now here you see, it takes all of the running you can do to keep in the same place. If you want to get somewhere else, you must run at least twice as fast." This is a very interesting idea, and I think it's one that doesn't get enough attention within IT. And I know it best from its application within evolutionary biology. There's an excellent book called The Red Queen by Matt Ridley. And the basic idea being that when you have competition, all advancement, right? Any advantage or any effort that you put into moving forward is only advancement in terms of how it gives you a relative benefit versus your competition. Okay, so it doesn't matter if you're moving 100 miles an hour if your competition is moving 100 miles an hour, and moving 100 miles an hour is not enough if your competition is going 120, right? So we're going to come back on this theme of the Red Queen, where moving forward is essential just to stay in the same place. So now we're going to get into a glossary and arbitrary disambiguation of some terms. Okay, so I think that a lot of these questions are still up for debate, and again, this is my stake in the ground. So first, the term DevOps. Looking around for definitions of DevOps, there are many, and they overlap, and they have many differences. But what I'm gonna settle on for this discussion is one from IBM's Kevin Minnick back in 2013. DevOps is an enterprise capability for continuous software delivery that enables clients to seize market opportunities and reduce time to customer feedback. Okay, that makes sense. I think some other features of DevOps that I think are worthwhile to focus on for this discussion are the ability to experiment, fail, and learn as a small team, clearly defined external commitments and expectations of others, the ability to measure outcomes, and the ability to match responsibility and capability. And already, if you look at this, and if you are thinking anything about machine learning or data science in general, there are some items in here that already should ring familiar, right? The ability to experiment and measurement. Okay, so I think we already have some level of overlap to begin with. So, all right. So where does Agile fit into all of this? Let's digress into Agile a little bit. So Agile and DevOps are different concepts. DevOps often relies on Agile, so they're often conflated. But Agile, I think, in itself should be discussed here, and these concepts should not be discussed as part of DevOps, because I think that's a little bit too much of a conflation of terms. And really, this is the whole point of this discussion is a pedantic discussion of terms, right? So let's discuss a couple of the ideas from Agile. These are 3 selected stanzas from the Agile manifesto. So deliver working software frequently, from a couple of weeks to a couple of months, with a preference to shorter timescales. Business people and developers must work together daily throughout the project. Okay, so tight integration between developers and the business people that you serve, or your customers, or whatever form they take. And build projects around motivated individuals. Give them the environment and support that they need, and then trust them to get their job done. Okay, so this I think is also quite key. So a little further digression into Agile as we've been as I've been exploring these concepts. Under the under the requirements from COVID-19, my family, like many others, was forced to adopt social distancing, and forced us very tightly into into our little cocoon here at home. We had two parents working white collar jobs from home. Our 6-year-old daughter was attending a hastily organized kindergarten. Um, I'm going to say here that we had significant existing organizational debt. Yeah, in that we were not the most organized people to start going into the crisis. So what do we do? We fumbled around for a few weeks, and then the idea came to me at a certain point that, hey, I spend a lot of my time talking about agile methodology. What if we tried that here at home, right? What if we gave that a try? So we implemented a daily stand-up meeting every morning at 7 a.m. We reviewed our daily backlog of tasks between the three of us, and added new things and prioritized what was on there. As an example, list over on the side here of the things that we would add to this list, right? Like, feed and walk the dog. My daughter would do her online Mandarin language conversation course, water the laundry, and we're also putting like just the stuff that I needed to get done for work on that day. So, review activity in Salesforce.com. My wife she's a ghostwriter, so she needed to do a cold read of a manuscript, etc. So what do we learn from that process? Well, we found that our backlog grew indefinitely, which if we were able to, we were able to clearly document that we were in fact quite understaffed for the work that was in front of us. Our individual talents were important, and that while we were trying to work as a team and look at the outcomes, the set of outcomes as a whole, we found that some of our individuals were much better suited to particular tasks. So, for example, my daughter is much better with Mandarin than I am, and I'm much better with Salesforce.com than she is, right? We also learned a bit about shifting left. So we found that our lunch deadlines were often much better met if somebody shifted to do the dishes in that morning, so the kitchen was clean when it was time to make lunch. And we learned also about our constraints and about failures. So, more than one of these Agile days ended with somebody in tears, which I'm told from people in the industry is not an uncommon occurrence from Agile. So let's move on to a little bit of disambiguation of different terms related to data science. So data science being a broad term that has underneath of it artificial intelligence, underneath that machine learning, and under that deep learning. I admit I'm a little bit sloppy when using these terms myself, but I think it's a good idea to just sort of baseline them a little bit. I am going to, in this presentation, focus mostly on machine learning. Okay, so machine learning, let's simply look at this in terms of the how this would work within a business setting. So we would set some sort of goal. We have some sort of objective that we would like to reach. You gather and prepare data. So that might be, improving the quality of the data, reviewing the data to make sure there isn't known noise or errors within the data. There's also a process of labeling the data. So the simplest, I think canonical example here is that if you want to build an ML model that can tell the difference, that can identify pictures of cats and pictures of dogs, in photos, you need to start out with a corpus of data that contains photos of cats, photos of dogs, and then you would go through ahead of time and label that. You put like a little box around each dog and each cat, and you would label it cat or dog. Then you develop the model, which is both a development and also a computational process of turning that labeled data into a mathematical array. that subsequent data can be compared against statistically. In an IT setting, you would then deploy that model as part of a development process, and implement the way that your applications are going to interface with it, and then you would monitor and manage the model subsequently, and then that would provide feedback back into further model development. And one would hope that this process would also provide, would also drive feedback back to the business, or back through a DevOps process to the folks who are setting goals in the first place. Okay, so here's my shot at disambiguating DevOps, MLOps, and AIOps. So DevOps we've already defined. MLOps means applying DevOps techniques to challenges that are well addressed by machine learning. Okay, so we are going to look for problems that are well addressed with machine learning, and we are going to try to attack those problems using a similar process as we would have used for application development under DevOps. And I think a reasonable analogy to think of here, when we're thinking about how organizations should look at how machine learning can be used internally, is to think about how, if you're within application development, you have a smart person plus an objective plus an algorithm, right? They spend some time thinking of how the algorithm should work. Then you add a programming language, or you write some code. That plus some time gives you a microservice, or gives you some useful software. So, okay, so smart person plus objective plus the algorithm plus the coding language, coding environment, plus time gives you some useful software. Okay, software that can respond to input and give appropriate output. Okay, so that analogizes, I think, to machine learning, because you could say, okay, smart person plus objective plus data, and then plus the resources that are necessary for training. This is the software and also the computational resources that are necessary for training, plus time, gives you a machine learning model. And in the end, that machine learning model is able to do similar things than some sort of algorithmic solution might be able to do. It might even be able to address the exact same problem. Okay, so how are they the same? You need a smart person, you need an objective, and you need time in both cases. In the case of software development, you work from an algorithm, and in the case of machine learning, you use data to create a model. Okay, but I think in terms of a first estimate, you can think of these processes as very similar in terms of how they should fit into the scopes of DevOps, or the scope of how you try to solve problems in IT with software in general. Okay, so my Venn diagram here. Okay. Oh, last concept here. So AIOps, and these are the two that I think are often conflated, and I don't think that there's any reason why these two terms necessarily couldn't mean the reverse. I think we just need two different terms for two different concepts, and so this is the this is Red Hat's stake in the ground of how they should work. So AIOps is applying machine learning techniques back on DevOps and IT itself. So can you use machine learning for log analysis? Can you use machine learning to look at the patterns of behavior within your incoming connections? Can you examine how your users interact with software using machine learning techniques? Okay, so that's what we're calling AIOps. Now, there's some overlap and some similarities here, and it gets really interesting where, let's say you have a DevOps organization. As part of what you do within your DevOps organization is you do some MLOps, because it's just one of the techniques you have available to you. And then on top of that, you also use AIOps to improve your own DevOps. So, really this can turn into like, a turtles all the way down sort of situation. But the place where they overlap is the famous pizza rule, right? No more than 2 pizzas per team. Whoever is doing all of this, they need to go back to those key values of DevOps, where you have small teams that are allowed to work independently to deliver based on feedback from their customers, and rapidly iterate. Okay. So another little digression here. So are the robots coming for our jobs? And I'm going to say pretty emphatically, no. Right? Will IT workers be replaced by robots? No. Will there be a difference in the rate of growth in IT? Right? Will the rate of growth slow, perhaps, or will it accelerate? Yeah, perhaps. And artificial intelligence may be, and machine learning may well be, one of the factors that leads to a relative growth or relative reduction in the rate of growth that we see in IT. But overall, IT workers are not going to be replaced by machine learning models. And there's a few key reasons for this. Number one, AI is fantastic for some problems, and it is absolutely terrible for some other problems, right? So, playing chess, great. Organizing a chess tournament, probably not so great, right? There are many cases where there are tasks that are very, very easy for humans to do, but very, very difficult, or perhaps not achieved by artificial intelligence at this point, right? Or only done badly at this point, right? So, the classic Turing test is just, if you communicate with the computer, can you tell that it's a computer and not a human, right? Then there may be cases where the Turing test has been passed in some contexts, but certainly not when it comes to picking up the phone, right? You definitely know when you're on the phone with the computer at this point, right? And many things related to what IT actually does have a surprising, have more to do with how those actually human interactions work than we might think. We might think we have technology jobs, when in reality, many of us have actually personal interaction jobs. And the other thing to remember here is, let's go back to that concept of the Red Queen. So indeed, so a robot and a human working together, so it's this human intelligence that is supplemented by artificial intelligence. Artificial intelligence that is used to do the things that human intelligence does really badly, right? Like be able to get answers out of large amounts of data, being able to make objective judgments out of based on questions that can be represented in data, right? Those are things that humans don't do very, very well, but we can do very well if aided by machines, right? So the robot plus human beats either human or robot that are acting independently of one another. And this is a Red Queen situation, right? Everybody is going to be competing with each other. We're all going to be looking for differential advantage against one another. And so everyone will continue to employ humans, even if they only create marginal value, because in a competition situation, in a Red Queen situation, marginal value makes a difference. So even if humans only make computers 10% more effective, it will still be worthwhile to have the humans there because that 10% edge will make you better than your competitors. So my answer is, quite emphatically, no, robots are not coming for our jobs. Okay, so peering into the future. And the nice Jeff Bezos quote here, which I encourage you to go look up about interfaces or working with APIs. So looking into the future, what are machine learning tools? Where do machine learning tools and techniques lead IT? Okay, or maybe I should broaden this out to to data science and artificial intelligence as well. So far, only challenges with a very high return on investment have been tackled using these techniques, right? So, for example, the internet ad market has been very well tackled because there was a massive return on investment available, and that's why Google exists and why they make so much money. But on aggregate, if you think about that across industries, or you think about it not just across what we do particular to our individual industry, so like Red Hat writes software, right? So there's a lot that can be done in terms of building and selling software for Red Hat. But there are all sorts of things that could be done just to improve our internal operations and improve how we get things done as a company. Artificial intelligence and machine learning can improve your garden if you want. So there's still a lot of room here. A major shift is happening to IT that's similar to the shift that happened when other industries adopted lean techniques from manufacturing. So lean, sometimes also known as the Toyota way. If you're not familiar with lean, I highly encourage you to look into it. And I mention this because I happen to know the example of lean being applied to medical laboratories very well. My dad happened to spend most of his career doing this kind of work, and they went very much from a science conducted on a sort of cottage industry basis, where you would have an individual laboratory tech that was basically trained in science. Conducting tests in a very like ad hoc or perhaps even individual way, perhaps not even uniformly to the person who would sign up for the next shift, and that was moved very much towards a manufacturing model where the large testing facilities that exist all over the world, like the huge ones from say Quest, for example. They are performing science in an industrial way that has been improved, and efficiencies have been drawn out of those systems as though it was a manufacturing plant that produced cars. So that's a major change. The industry is completely unrecognizable. The same thing is going to happen to IT in terms of the implementation of artificial intelligence and machine learning techniques. It's going to be that big of a shift. And one of the questions that we have in front of us is, is our industry going to change willingly and in a productive way and very rapidly, or is this something where we're going to change as companies go out of business because they can't compete? Or are we going to change as people retire, right? And as new people that don't know the old ways come into the industry, right? That's really more the question we have in front of us. So the knowledge of these techniques has become much more widespread, and the cost necessary, and back to the earlier comment on the ROI for earlier challenges, the cost for the resources and tools needed to implement machine learning are falling dramatically due to commodity hardware and open source software, and of course the pressure that the very large gaming industry put on the price of GPUs. which had this turned out to have this other ancillary use in accelerating machine learning workloads. So we can thank gamers for that. The other thing, concept that I really want to get across here to my audience is that we are on the cusp of something great. Something amazing is happening right now, and using machine learning, the variety of problems that we'll be able to address with applications and just with our work within IT are going to increase dramatically. Okay, so there will be many sorts of problems that we would not have even considered tackling before that will now become just part of our normal operations, and that's a very exciting thing, in my opinion. It's going to be a great thing to see. So I have a scale. I want to talk this out in terms of the opportunity in front of us, using a scale that I devised that came nearly completely out of my head, and that I am convinced is mostly wrong. But there's a saying from data science that all models are wrong. The question is whether or not they're useful, right? And this model that I've come up with here, I think, is probably mostly wrong in terms of all of its individual particulars, or many of its individual particulars. But I think it's still useful as a whole. So let's talk about that a little bit. So we're going to call this Berrie's incorrect scale of AI penetration on a per industry basis, right? So in my arbitrary scale here, I'm going to define Class A as the industries where AI is so prevalent that if you are not a heavy user of it, you simply cannot compete at all, right? You're in the process of being driven out of business, and you may be relying on other competitive advantages for the time being, but unless the dynamics of the situation change, it's going to be very difficult for you to maintain market share and revenue, right? So advertising, marketing, retail, social media, these industries are heavily penetrated by these techniques, and much of the technology and the techniques that we are going to be working with were modernized and popularized, and they may even be open source projects that came out of these companies, right? So these are the industries that are really leading the way. And these are also industries that are generally not Red Hat customers as much, or the huge players in these fields are don't tend to do these things on their own. So I'm not going to focus on them that much. So Class B would be case where competitors who are lagging, right? Data science or AI is prevalent in the industry, and so anyone who is in the industry that has not gotten on board with what is now the norm in the industry is currently facing a huge competitive disadvantage, right? So finance, insurance, energy exploration, sports, all of these industries have gotten a lot of press in terms of how much they benefited from these techniques. Let's get down to classes C and D, and this is where things, to me, get a little bit more interesting, right? So if you're in Class C right now, the competitors are enjoying significant advantage insofar as these technologies have been adopted, right? Information technology, utilities, healthcare, manufacturing, transportation, tourism, real estate, defense. It's not commonplace at this point to apply artificial intelligence techniques towards their endeavors, but those who are leaving their competitors behind in the Red Queen view of this. And then we have class D, and I apologize if you are if you happen to be someone who works at one of these uh, or an organization from this segment, and you're going to tell me no, actually we're doing this and we're great, and we should at least be in class C. I apologize if that's the case. Good job. So civil government, education, construction, agriculture. These are cases where these techniques don't are not used as prevalent, and large opportunities exist to advance against your competitors if you adopt these techniques. So again, I don't want to say that my judgments or my guesses in any one of these particular areas exist. Like, we can reshuffle this a bunch of different ways and make it less wrong than it is right now. But I simply want to point out that there is a class like this. There are distinctions. There are industries that are ahead of others. There are segments of industries that are ahead of others. And especially if you are at one of those C or D organizations or C or D markets, the benefits that are available to you with these techniques are massive, and the ROI is huge. And even if you are up in, say, class B, the question should not be, okay, great, we're doing what we need to be doing to compete within our industry. The question should be, okay, since we have all of these great facilities for data science and machine learning, what other challenges can we apply that to, right? What are the lower return on investment challenges where these techniques can start making sense, right? So those are the questions we need to be asking. So what are the risks here? So the question for IT professionals, and I touched on this earlier, is will we integrate data science techniques into the discipline of IT in the light of what we have already learned from DevOps? Or will data science end up standing aside as a separate priesthood, right? Will that mentality of the throw it over the wall system, right? Will models be thrown over a wall to operation teams? Much in the way that application code was once thrown over the wall to operations teams. And will data science practitioners, as they proliferate, will they find themselves estranged from IT in the way that IT is sadly often estranged from the business or the customers that it supports, right? And that's what DevOps is meant to fix, but obviously DevOps is not everywhere, or another system that works as well as DevOps isn't everywhere. So this does happen, right? Are we going to see the same mistakes repeated in a separate domain of technology, or are we not? So lastly here, the path forward, at least from Red Hat's point of view. So how do we get here? What does Red Hat advise? So, if a client comes to me and says, well, what do we do here? We talk about adopting open architectures, open processes, open cultures. The process and culture stuff I've talked about mostly here. So when it comes to, I'll leave those aside for now. They're the most important things, but for the rest of this presentation, I'm going to focus more on the technology side. Okay, if you're talking to Red Hat about this, what are we doing, right? So we have the conceptual model of a ML technology. Underneath of that are the ML and DevOps tools, right? Things like TensorFlow, Jupyter Notebooks, Python, Seldon, accessory. This is the actual application platform that your data scientists will use to get their work done and use to collaborate with other members of a DevOps team. There are the data services and pipelines. This is connections out to the data lakes. Also, things like streaming technologies. There are then we would obviously recommend using hybrid multi-cloud platforms with self-service capabilities. Are the people that are working within these teams able to get the resources they need when they need them? Are they empowered? Right. That's really what that's about. GPU, your compute acceleration is very important, and Red Hat has put a lot into that. And we at Red Hat believe that it's very important to remain flexible in terms of how the underlying infrastructure works. Different workloads fit in different environments significantly better, and there are, interesting problems around lock-in or lack of flexibility if you commit fully to any one of these types of infrastructure. So we recommend maintaining a hybrid approach to infrastructure. So what does that look like? How does this map to some Red Hat products? So software tools, the Red Hat Decision Manager tools and process automation tools make it easier to have a framework to work with the business and to perhaps even offload some of the logic of how business processes work to business analysts rather than having to see that get operationalized in code. Our runtimes tool, runtimes tooling allows you to build the right kinds of applications for agility in this sort of environment. For data pipelines and services, our integration tools are solid. Red Hat AMQ, including AMQ Streams, which is our Kafka distribution, Fuse, which is our Apache Camel distribution. These things are coming together in a very interesting way with OpenShift at this point. Basically, the whole stack above that is coming together into event-driven architectures that are, function as a service kind of architectures that are similar to what you might have seen with, say, AWS Lambda or the badly named serverless architecture, but more widely applicable and more customizable for your needs than the sort of kind of one-size-fits-all that you get out of existing functional as a service offerings. And then underneath, software-defined infrastructure, right? So being able to connect to those GPUs and having the the container storage and virtualization platforms that you need underneath to support it. Working in an open source, open community is key to all of this. The project that we use to bring together community collaboration is the Open Data Hub. It's our way to work with partners to create operators so that their tooling works seamlessly on top of OpenShift. And much of this, of course, applies also to Kubernetes. This is an interesting space because there are many different ways to solve the same challenges, different approaches that are preferred by different teams, and with good reason. So Red Hat is trying to be more of a general friend to many partners than trying to necessarily pick winners in this space. There are a few places where we have made commitments, for example, to Kubeflow, which is a way to drive machine learning workloads on top of Kubernetes or on top of OpenShift. And we have a very large spectrum of third parties that we're working with. It's frankly difficult to keep track of all the different ISVs, hardware partners, and major partners that you might not think about as being key for Red Hat. Like, for example, we're doing great work with Microsoft right now around making data-driven applications available for users and running on top of OpenShift. So if you have questions about this stuff, talk to your friendly neighborhood Red Hatter. There's a lot we can go into here, but I just want to give you a view of Red Hat's approach when it comes to technology. All right, so we got 10 minutes left. Diane, any questions in the chat?
There are a couple. Faith just asked, any hardware acceleration with Edge TPU with Google/Coral? Google Coral I hadn't heard of before, so I'm not sure whether it's on your radar.
Mm. Uh, TPU, so tensor processing units. Not supported yet within OpenShift. It's an area that I think is considered emerging. Right now, the work that we've been doing with NVIDIA to make scheduling of GPUs a possibility is going great. It's fully supported within Red Hat.
Yeah.
We're going to see better FPGA and TPU support going forward.
I think we just did something, I think I just saw a reference architecture float out yesterday around the Dell reference architecture for GPUs. Diane Fedema did something, we'll probably have
Hmm.
her on that.
Hmm. Hmm.
But I haven't heard much about TPUs yet. So I think that's still a work in progress or some research that we
Hmm.
probably need to do. You mentioned really early on in your talk, which I have to say, one of the things I think the outcome from this talk should be a book reading list, because you mentioned so many different books, but you
Uh-huh.
mentioned a Red Hat machine learning book. Was that a book or is that
Oh, so we have an ebook. You're right. I should reference that ebook. I'm not sure that I do in this. Um, uh, I, I'm not sure. I don't mention the Red Hat ebook in this. I should. We have have it on my machine here. What's the title again? Um,
yeah, if you can, not
just
right this instant, but just send me a link to that. Waleed was asking for that early on. Um,
Yeah. It's hold on a second. It is.
and Chris is talking
It's called
OpenShift.
the book's called Top Considerations for Building a Production-Ready AI/ML Environment, and yeah, it's a free ebook that's available on our website. We'll throw the link in the notes, and I think it does do an excellent job of giving you a sort of corporate overview of what the challenge is in front of us. Perhaps less about the sort of higher level concepts, but more about what the opportunity is and how you would apply this. So yeah, very much informed my thinking around this.
Yeah, I think somebody finally found the link and threw it in the chat. That's great. Thanks.
Cool.
Beverly, you had a question. Wondering if you want to unmute yourself and ask it. Um,
Yeah, absolutely. Zach, that was a really great presentation.
Thank you.
And I'm also interested in hearing your thoughts on the risk that organizations face by deploying machine learning models without proper MLOps practices. Is it possible?
Yeah, it certainly is possible. I mean, and this is something that you could completely outsource, right? I mean, and I think that a pattern that we're seeing in the field at this point is that a line of business that has a budget and has a business problem with a large ROI may go out and hire an SI, or they may hire their own data scientists, and they may just use AWS, or they may use Azure, or one of the public clouds for Google, um, to perform data science work. Perhaps get the insights they need, perhaps build some models, and then in terms of how that will translate into how it fits into an overall application architecture, it will turn into a sort of thing where, like, hey, a line of business as a whole could look at the people that are actually running the production applications and say, hey, we made this thing, now go run it, right? Or you this has a lot of value. You need to now make sure that it stays up 24/7 and gives the results it wants. Or we need you to shoehorn this into your architecture, not as part of a coherent whole. So and if you think about it in terms of how our feedback cycle is going to work, are you going to be able to coherently manage how that application works as a whole moving forward? These are all the sorts of challenges that DevOps is supposed to address. And if these techniques are utilized in an incoherent way, a lot of those benefits will be lost.
I also thought there was in your diagram where you had the AIOps, the MLOps, and DevOps, and the pizza diagram there.
Yep, you're right.
I really liked the way that you said applying AIOps equaled applying machine learning back on DevOps and IT itself. And I see that even at Red Hat now, you know, in the telemetry and looking at where people are going, applying that to the back end of OpenShift and all the different, you know, flavors of hosted OpenShift so that we can see, you know, how clusters health are doing and notifications. So I think there's a huge opportunity. And I think your landscape diagram at the end pointed out a few of the folks who are doing some really cool things in AIOps. So it's the emergence of these two fields spun out of DevOps and these DevOps practices is really what I think is empowering the use of ML and AI in a lot of organizations, and organizations that just use ML or just try and train something on one set of data and don't like incorporate it in the whole workflow are missing out on a big chunk of the opportunity here. You know, when we see some of the work that you know, there's been a lot of Red Hatters volunteering on COVID tracking projects, and so we're seeing sort of one-off applications of using the Open Data Hub reference architecture. But the opportunity is to tune that architecture and to apply MLOps to that that Open Data Hub, or you know, whichever architecture you're using, to really take it or level up your organization's use of ML or AI wherever, you know, whichever side of the fence you're on there. If you're on the admin IT side, or if you're on the training data models and doing data science research.
Yeah, and I think this is something we're going to end up seeing in terms of OpenShift. So as machine learning as a workload becomes a commonplace workload on top of OpenShift, right? You know, part of every large environment, or you know, or one of our common deployment types. You know, a thing that you see in OpenShift already is that the tools that are used within OpenShift to the advantage of people that are managing applications, right? So things like, you know, Prometheus and, you know, the monitoring tools and so on, that we take those tools and we turn around and apply them back to the platform itself. Okay, so as it becomes commonplace to use these techniques for OpenShift workloads, we are also going to see a proliferation of using the techniques for management of OpenShift itself. I don't know how long it's going to take to get there, but I know that I know that the work's underway.
Yeah, we're doing. Yeah, I get to see little glimpses of it every once in a while, and it's pretty amazing. So I want to just take this time, if you can go back to your final slide, maybe the landscape slide there, and then just to thank you. And a number of the folks that are on his landscape slide have done past OpenShift Commons briefings. Profit Store has been on. We're having, you know, a whole lot of these guys come and give talks, and Starburst has been on, and Cloudera and NVIDIA. And
there's a Converge.io talk starting right now.
Yeah, right after this one. So if you want to pop the link to that in, if people want to jump in there, that would be great. But there's a ton of content that is going on, and there's lots of great work going on in Red Hat and elsewhere. And really, Commons is what we're trying to do is get you in that fire hose, make it useful. And Zach, I have to say, I feel a little pity for your daughter or your son who's having this agile training and upbringing, but I think it might be useful. And I wanted to really thank you for taking the time today, and Beverly and everybody else for coming and with your questions and participating in the conversation. It's great. We'll definitely have you back and do some deep diving on this and try and get some more of these Commons members and partners on board, especially the ones that have operators that already work with OpenShift, We have a push in the next coming month to get as many of the certified operators to do, to show off their stuff, to make this easier for everybody. So thanks again, and we look forward to hearing from you again. And
thanks for the opportunity to come speak.
Yeah, and we've got to put together a book list to reference for this, because I'm going to have to go out and read that Red Cream book and a couple others that you mentioned. So thanks for the reading list. So take care, everybody.
Thanks. Bye-bye.